title. Okay, that's better. When I refresh it. There we go. Okay. Make sure that seems good. I think that's good. All right. Same deal as usual. We have the live chat in Piazza and on Echo 360, which I am watching. So if any of you have any questions that you'd like to ask, feel free to do so now. We are quite low today. That's all right. Just refresh that for good measure. Yep. Okay, so this week we're looking at event handling in practice, and we've been focused on a particular software design pattern that's used to manage event handling across loosely coupled systems, and that is the observer pattern. So in the before lecture reading this week, we were looking at the fundamentals of the observer pattern and the basic software architecture that goes with all of that, and some bits and pieces on how it gets used and whatnot. And I'm assuming everybody is familiar with that basically. So today what we're going to be doing is we're going to be just looking over a practical implementation of the observer pattern. Hopefully you've already seen the example code for that, so this should mostly make sense, but we're just going to go through that example code in a bit more detail, write an observer from scratch just to really hammer the point home. And we're also going to look at how observers are used in practice and look at how they get used in the context of a graphical user interface framework. Okay, what's happening? Programming assignment 2 is available. It took a little bit longer to get out than expected, so sorry about the delay on that, but that's been up since Friday, and it will be due at the end of week 9. That does run through the mid-semester break. Start early on this one and plan your PetriNet. I'm going to be smashing out a bunch of zeros for people if they don't use PetriNets for this, because it is a PetriNet assignment. So just be aware of that. I think it's written enough times in the assignment specification that it'll be hard to miss, but nonetheless, let's not have the conversation where I give you a 0 because you didn't use PetriNets in your assignment that was about PetriNets, because I know that's a problem we've run into in the past. Workshops are on this week. That's a thing too. Hooray. Okay, observer pattern. So we're just going to start off by having a look at some basic code for the observer pattern. We're going to implement that code from scratch, and I'm going to move this second keyboard away so I don't accidentally type on that instead. There we go. So we're going to implement an observer pattern from scratch. So as we recall, the observer pattern is a design pattern that we use in systems where we need to be able to connect. There we go. Where we need to be able to connect multiple event handlers to a single event source. So far in this course, we've been looking at these very rigid systems, rigid state machines where you have a distinct state and you predefine in your code, you hard code in how the system should handle each possible input at any given state within the system. And we primarily handle this by transitioning from one state to another when when we receive specific inputs, that usually triggers a transition to another state. It doesn't necessarily have to, but we looked at specifically how we would architect that type of system. But we don't necessarily always know. When we start our programs, sometimes we need to dynamically add event handlers to those programs. So let's go and so with an observer pattern, we essentially have a subject or something that is being observed, and when we want to handle the behavior that occurs when something on the subject changes, or just any time the subject triggers a particular action to occur as a result of something that has occurred on that subject. And it doesn't necessarily have to be from a specific event source. It can be a combination of different things that triggers that behavior change, or that triggers the subject to react and then ultimately trigger its listeners. But what we want to do is we want to provide a way that we can register to be effectively notified when a change occurs, and when this notification goes out, it effectively triggers our own behavior to occur. If I could spell, that would be good. Okay, so in Java, the way that we implement observers is through polymorphism and interfaces. So because Java is so heavily inheritance-based, and it's rigidly typed. So in other programming languages like Python and JavaScript and some of those programming languages, you might just see it, and also just straight C for that matter. What you might have is, you might have, in the case of C, you would be passing a function pointer. In Java and Python, you might pass a reference to a function that just gets called whenever a particular event occurs. In Java, where you have this more rigid typing and you can't just pass functions around, we have to implement a class that implements the function that we want, and then the way that we make sure that we are dealing with the correct classes is that we then implement, or that we have an interface that we can apply polymorphism to. So interfaces in Java, for those of you who are familiar with C++, interfaces in Java are like pure virtual classes in C++. So we create an interface or a pure virtual class that defines a method, and then that method is available on all implementing classes, and then we implement classes for each separate behavior that we want to define to occur when the event gets triggered on the subject. So let's go ahead and start by creating, so we're going to need 3 files effectively for this. We're going to need, in this case, okay, so we have our observer, that's going to be our interface. We have a implementing class that is going to be a practical implementation of that observer, and we can have as many different implementations as we want, and they can all do different things. And then we need a subject, so I'm going to add a subject class. And this other file that you see over here, button example, is for later. Okay, so we're going to start with the observer file, and we are going to declare it as an interface. Like so. So again, if you're familiar with C++, we're declaring equivalent of a pure virtual function or a pure virtual class. It's just that JavaScript or Java separates that out as its own completely separate thing than C++ does. C++ just allows for multiple inheritance. Java does not allow for multiple inheritance. So then what we're going to do is we're going to define that it has a function. I'm going to call it update. And it's just going to be a void function. And that's it. So anything that implements this interface is going to have the update function, and we can call the update function on any implementation of this, and that's how that's all going to start working for us. Let's open up these other two files here. Okay, all right. And we're going to take a look at the implementation of this. Okay, so create a new class, declare that it implements the interface. I'm going to give it a constructor. And then we're also going to give it a, we're going to make it implement the function. So the function signatures have to match, as you can imagine. So then whenever we create an instance of observer impl, it's going to have this update function, and this update function can be called by the subject because it's an implementation of the observer interface. So then we can do whatever we want to do here. I'm just going to, do some system printing. So, there we go. And that's pretty much that. And then finally we have the subject. And the subject is the thing that actually acts as the source of our event, or at least when an event occurs on the subject, that's when we want to trigger all of the observers. So what we have to do is we have to provide a way to add observers to the subject so that we can create as many different observers as we want. They're all going to be instances of the observer interface, but they can be different instances. So actually I'm going to create a second observer in just a moment after we've written our subject, and we can then go ahead and add as many as we like to the subject. And then what the subject needs to do is whenever an update occurs that results in the subject needing to notify all of its observers, basically enact some behavior whenever an update occurs, instead of hard coding that behavior directly into the subject, we have the subject trigger all of its observers and then they all run their respective behaviors. So let's code this up. We're going to need some kind of data structure to keep track of all of the instances of observers that are attached to this subject. And we need to create a method where the subject can add new observers and remove existing observers. So let's go ahead and declare the class and give it a constructor. And we'll come back to that. So we're going to need, and while I'm at it, let's add some nice comments in here. So this is Okay, so we have a method here that allows us to, we can call that method to add observers to the subject, and we pass the observer as a parameter. And we also usually want to have a method to remove observers from the subject, because there might be times when you want to delete an observer or you're done observing that particular subject, so you can remove the observer from there. So that's what we're going to do. That seems good. Now this one's private because usually it would be called from within the scope of the subject itself. So if the subject's doing whatever it needs to do and something occurs that results in a notice, well, not even a notice, but something that results in all of the observers or listeners needing to be triggered, then we can call the subject's doUpdate function, and that subject is then going to be able to notify all of its observers. So we just add some nice comments in here for good measure. Spell that properly. Okay, and there's our basic structure there. So what do we need to do? We're going to need a data structure to keep track of all of the observers that are attached to the subject. There's a few different ones you can use. Typically this is done with a list. I think there's an argument to be made for using a set for this, but usually we do actually allow in this architecture you to apply the same observer multiple times to a given subject so that it can be triggered multiple separate times. There might be reasons why you want to do that. So in this case I'm going to use a list, and I'm just going to use a linked list implementation. So linked list. I think you'll see in the example code, oh, I should actually declare what type of linked list it is. In the example code you'll see that it's just list, but list is not an actual implementation of a list in Java. You need to specify what type of list you want to use. List is like an abstract class, effectively. So.
It's observer type. Yeah.
Sorry?
It's gonna be observer type.
Yeah.
Yeah, I was gonna again. Why are we not using set?
Well,
Because it would be much easier to implement it. Create it like tree set.
yeah.
I guess
Again, there are cases where you might want to explicitly add multiple of the same observer to a subject. Yeah, to have the same behavior be triggered multiple times. So it's usually done with a list, not a set, but it can be done with a set depending on your preference. Yeah. And that's that. Okay. Right, and then these become pretty trivial. It's a list, so we can just add directly to it. and we can remove directly from it. Java's list methods are really straightforward, and they provide some that we don't have to search for things, which is nice. We can just call remove, and presumably that's a linear search in the list, depending on the type of list implementation. Okay, so we have add, we have remove, and then for our update function, we then loop over the list, or we iterate over the list, and we trigger the update function for all of the observers that are in the list. So we can use a for loop for that, and we can use this is a for each loop in Java if you haven't seen one before. And then we invoke that function. So in this case, we use polymorphism to our advantage. We treat all of the instances of the observer interface as just generic observers, and we call the update method for each of them because an interface is abstract. Because an interface is abstract and there's no generic implementation that can get called, it's always going to call the implementation of that particular instance of the observer class, and that's why that all works. So we have subject.
So on do update, we are taking basically the whole list.
Yeah, we trigger it one at a time for every observer.
Oh yeah, makes sense.
Okay, so that's that. Now we might just add a couple other observers in here for good measure. We have a second class called observer implementation 2. And I might give it a can't type say private static. Might add a static variable. Just so that we can keep track of different instances of it. So I'm just adding like a counter here, so each instance of this observer is going to have a separate number value, or this num value. So the first one we create will have a value of 1, the second one we create will have a value of 2, and so on and so forth whenever we access the this num variable, and that's just because we're using Java's static variable up there. So then we can say, yeah, sure.
So private, line number 5, private.
Yep.
Is this a type of observer?
Oh, hang on. Yep, thank you. That's better. It's just an int. Yep. Good. All right, so that whole class is an observer, the second one's that's good. And now we can go ahead and create a main class. Let's go ahead and do that. Although if we wanted to, we could probably put the main in the subject. You know what, I might just put main in subject for argument's sake. No, actually no, I'm not. We'll do this the proper way, not the hacky way. Okay, so then we've added those ones in there, and I'm going to add a main method to this one. And what we're going to do is we're going to create a subject. And we did make do update private, so we're probably going to need to add some other method that's actually going to result in some triggers happening. So public going back and forth here, print line. And if we wanted to as well, something that commonly occurs is that the do update method is going to take a parameter, and typically that parameter will contain some information about the event that has actually been triggered. So usually it would be like an event object, some sort of object that contains information about the event itself that has occurred. That would also get passed to all of the observers, and then all of the observers could receive information about the event. We'll see an example of that in the next example. But
I think on line 36 where you define the function called some event.
I do have to, oh no, this is a good point. I have not been putting in return types on any of these, have I? Okay, so out of observer is void. One could potentially return on remove observer. I'd have to check the... I think the remove method off the top of my head, but I could be mixing up languages here, but I think the remove method off the top of my head also returns the object that gets removed.
Whatever gets removed.
So
I'm not sure.
I'd have to double check that. I can double check that. Let's pull up the API for good measure. When in doubt, Java API list remove. Okay, here we go, list. That reminds me, I also have to import the correct thing for that. Let's do that quickly while we're here. Import tilde. There we go. Okay, remove. Oh, it's a boolean. And returns true if the... Let's just make it the boolean for good measure. Pass that straight back up. Okay, that's better. That looks good, that looks good, that looks good. Have I missed lots of other... Yeah, no, that looks good, that looks good. Okay. Right, so we were creating a subject, and we were then going to be creating some observers, and we were going to be attaching them to the subject and then doing things and seeing how that all works. So subject. And then also we're going to go with 3. We're going to go one of the first type of observer and then another of the second type of observer. And then we can attach those to the subject. So dot add observer and if we were to trigger the event at this point, we could do my subject dot, what did we call it? I think we called it some event, yep. We'll add the third one twice, just for good measure, so that we can see how it works with multiple of the same one. Then I think that should be enough. Okay. Let's hope it all compiles. I think we've picked up enough errors that hopefully this should work. So nope. Oh, so many errors. What did we do? I spelt things wrong. Does that mean I've spelled it wrong somewhere else as well? Probably. I have spelled it wrong in a few places.
Oh, in the function as well.
Thank you.
Also in the previous class where you
Yeah.
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 Just with it. Class. Oh wait. Oh, sorry, function. Yeah.
Okay, I think we're good. Fingers crossed. Second time lucky. Almost. Okay, what have we got? Invalid method declaration.
So return type. Oh, return type for public observer.
Does a constructor need a return type?
Is it a constructor?
It's supposed to be a constructor.
If it's the constructor, you need to write the constructor name is wrong.
Oh, right. Yep. Okay. That's. Thank you. Okay. Third time's a charm. Let's do this. Okay, we got there. All right. Okay, and hopefully that sort of makes some sense. Let's walk through this. So each time we have the event being triggered, it's going to print an event has occurred because that's what happens in the subject. But then it has to trigger all of its observers in turn. So the first time around, we added a single observer of just the regular observer implementation. So that's that showing up there. We then added another observer and triggered the event, and you can see that both of these are getting triggered in turn. We then added the third observer, and that was another instance of observer implementation 2, which meant that because we had that whole static variable set up, it's got a different number. Here it's got the number 2. We added 2 of those, so you see it got triggered twice because we were using a list rather than a set. And then we went ahead and we removed the first instance of observer implementation 2 and reran the event, and you can see that it triggered all of those again. So this is a fairly fundamental design pattern in event handling, which is why we're spending some time talking about it. Does anyone have any questions before we move on? every time we want to have, so the question was, every time a new event happens, do we need a new observer implementation? No. This was just an example to see how we can have multiple observers attached to a system and how the system responds when we have multiple observers attached to it. Every time you want different behavior to occur as a result of an event, you need to attach a new observer to that, the thing that's being observed every time you want, like, to add additional behavior or change the behavior that occurs as a result of an event occurring. If you have predefined behavior in an observer or listener function, then you either need to remove and replace or add another one depending on what you're trying to achieve. Okay. Anybody in chat have any questions they want to ask? Or on Piazza? I'll just give that a minute. All right, well, I'm still watching it, so if anyone has any questions, just ask them. We're here, not going anywhere. So, that said, let's move on. We have another example here. I'm just going to click that up a little bit. This pattern gets really heavily used in graphical user interfaces, so I wanted to show you an example of this in practice, because what we just looked at was like, okay, well, that's kind of abstract. Where did the actual events come? We haven't really talked about where the actual events come from. The events get generated somewhere, and so far we've all just been, pretty much all throughout the course, we haven't really addressed where the events themselves come from. We were like, oh, a button gets pressed, and it's like, how does the button get pressed? How's that trigger in the system? I mean, it gets triggered through a variety of different things that can be like things like interrupts or system calls, and that sort of goes into hardware architecture, which is a bit away from what we're doing. We're focused on the software architecture of how we actually code for those sorts of systems. But as was noted, I think in a previous lecture by someone, it's a very functional way of programming. That's pretty much event-driven computing, sort of in a nutshell. It's a very functional way of programming. You define the functions that get triggered when specific behaviors occur, and then everything that we're doing is just focused around, okay, well, what's a good way to design for this type of programming? So we had the idea of state machines, these functions that get triggered for each different type of event, and then how we handle the fact that these can occur at any time. And all of that still applies here. But now we're just looking at, okay, well, how do we deal with a system where we don't necessarily know what those functions are going to be ahead of time, or where they could potentially change. So this is something that's very commonly done in graphical user interfaces, because you create a framework, you create an API, and you have all of these components and things that can have buttons, or that have events that can trigger on them, like buttons and input boxes and those sorts of things. And it's like, okay, well, I don't know what all of the behavior that the person who is programming for this graphical user interface framework is going to want to have when they create a button. The button doesn't know what the button's behavior is going to be when it gets created in a graphical user interface framework, because it's just a generic button at the time it gets created. So you have to have a way of saying, okay, well, you create the button and then you define the behavior that applies to the button when the button gets clicked. Now, there's one way that you could do that, is you could have like button as a superclass that gets inherited, and then you overwrite the behavior of the button for every instance of the button that you create. But that creates a whole lot of crazy inheritance stuff that you have to potentially worry about. So the observer pattern gets quite frequently used. This is also the case because sometimes you want multiple buttons to trigger the same specific behavior, the same specific function. So doing that with like redefining it through inheritance every single time isn't necessarily the way we want to go with that. We use the observer pattern in many of these frameworks. So let's take a look at what that looks like. Did I open that? Nope. Wait, did I? No, I already had it open. Okay, so what I have here is a basic graphical user interface. I haven't actually implemented the listeners or anything onto this yet. They call them listeners in Java. But I have a very basic graphical user interface in Java using AWT and Swing as my user interface libraries. So I have a frame. A frame is what Java calls the window itself. So I have a frame. A frame has a panel on it that is where I can put the content. The content panel is set with a particular layout. This is going to result in the content stretching to fill the window, so we're just going to get like a really big button, a window with just nothing but a really big button in this case, but we can play around with that in a little bit. We have a button and we have a label, but I haven't actually used the label anywhere yet. So then what do? We create the window, we create the panels, we attach everything into the hierarchy. So we set the window size to 640 by 480, we create the button, we add it to the window, and we tell the system what to do when someone closes the window and set its minimum size and then make it appear. And if we do all of that, when the system gets started, you don't actually... So normally when we run our programs, right, this would like just run one line of code and then stop. But in a graphical user interface, creating the frame like spawns a window and the system stops when the window is closed. So that's how that works. Let's go ahead and compile and run this. Hey, it's a window. The window has a button. Doesn't do anything, but I can click it. It's there. That's nice. And you can see that it closes. It stops the program when I close it. So then the question is, in Java, how do we go about adding behavior into this button? How do we actually make the button do stuff? And the way that we do this is by applying the observer pattern. That's the way that they do it for the graphical user interface. They call them listeners, and you might see listeners being used as a observer and listener being used interchangeably depending on what language and framework that you're working with. So what do we need to do? Well, first we need to, in the example that we did before, what did we do? What was the thing what did we do to apply the observer pattern?
Create a event listener and then pass it.
Sorry?
Okay. Create an event listener and then call observer class every single time it's clicking.
Yep.
And then we can set a behavior based on it.
Yep. Yep. So now we defined our own listener class, but Java uses its own. Java already has one defined for us that we can use. In this case, I'm using one called their implementation is called the action listener class, or this particular implementation that I'm using is called the action listener. I think there's a couple different ones that you can use in different contexts. I'm using the action listener one. So I'm going to go ahead and define an action listener. In this case, I'm just going to do it as a nested class. So and what am I going to call it? I'm going to call it button listener because it's a listener for the button. And it just so happens that I already have the action listener library imported as one of the imports up the top there. Okay. So we're going to have our constructor public which is just empty. And then the method that they used, now we created a method in the previous example called update that we triggered. Theirs is called action performed, or that's the particular one. Different listeners can have like different sets of functions. So like in the one we were looking at before, we might have different types of events that could result in different types of behaviors. So we might, in our interface, define rather than just like a generic update event, we might have, you know, update A, update B, update C, or, you know, depending on what the type of list is. So maybe it would be like, I don't know, keyboard event, mouse event, those sorts of things. And, you know, every action listener contains, or every instance of the observer would contain like a keyboard listener and a mouse listener, and then when you implemented it, you would have to implement both keyboard and mouse listener on each implementing class. However, you get to decide what happens for each of those two. So sometimes it makes sense to define multiple ones. In this case, it's just action performed that we are overriding here. And as we discussed before, sometimes they will pass an event in. So in this case, we have an action event object which contains information about the event itself that has occurred, which we can access and do stuff with if we want to. But this one, I'm just going to do out. Something like that. And that's that. So we've created our observer class, and then we can go ahead and create an instance of it. I'm just going to do that here. So and then we just have to attach the listener to the button. And now when the button gets clicked, that's going to trigger the action performed method of the button listener, of this particular button listener. We can have multiple button listeners. Yes?
I think you forgot to write call action perform. Oh no, again, all good.
All good? Sorry, it's hiding down the bottom there.
Oh yeah, and then
Yep.
right.
All good. Okay, let's try compiling that again. And now we run it again. And when we click, we now have it at the bottom. The button was clicked. As we saw before, this is all dynamic. So if we wanted to, we could, for example, create a couple other buttons. So what I'm doing is I'm just adding these additional buttons onto the window. So button 2 and button 3, add them on there, and I'm going to create another button listener. Fascinating. Why am I using hard tabs? That's not right. what this one's going to do is I am going to add a new button listener to the first button. And I think this works because of variable scoping. We'll find out very quickly if this doesn't work. So button dot
every button has to be assigned a button listener?
well, if you want them to do different things, then yes, every button has to be assigned a button listener. So in order for the button to actually do something when it's clicked, it has to be assigned an action listener, and the action listener defines the behavior that the button does when it gets clicked. So yeah, that's that. In this case, if you want each button to do something different, then you have to create a new action, or a new class that implements the action listener, and then a new instance of the action performed method that will run for that particular button. In some instances, you could, for example, use one action listener and apply it to multiple buttons, and then determine which button the event came from, and then depending on which button the event has come from, you could then depending on which button the event has come from, you can do different actions based on the button that was clicked. So you could create separate classes for each one, or you could have like one class and then track which button is the source of the event when the event occurs.
Okay, so I could implement several action listeners for different buttons.
Yeah, absolutely. Which is what we're doing here.
Oh.
Okay, so here what we're going to do is we add a brand new instance of the button listener every time the add button is clicked. That's what we're going for there. And button listener 3 is to remove them. And so we're going to do button dot get action. I think this is, I'll have to check that I've got this right in a moment, but okay, we'll see how this goes. This could just become a complete train wreck, but we'll find out. So we're also going to need to create instances of each of
Can't we just create 3 functions inside button listener and just call all 3 functions?
Yeah.
But yeah, again, it's the button.
if we created 3 separate functions in button listener, because of the way that the polymorphism is being used, when you have the action performed, like the action performed function is the function that gets called. So the question was, couldn't we just create 3 separate functions inside the one of the button listener implementations? Because action performed is the function that always gets called when the button is clicked, there is no way to differentiate between different action performs. You can't have multiple action performs in the same listener. Does that make sense?
Oh, yeah.
Yep.
And it takes only one parameter, which
Yes.
Because I was thinking, why can't we give some fake parameters?
Well,
3 or 4.
yeah, so as I mentioned before, action event does contain information about the source. It does contain a bunch of information about the event that has occurred. That information includes the source of the event, which is a reference back to the actual control that the event came from. So you could check to see what was the source of this event. Was it this button? Was it this button? And just do like an if-else. Where I think you can do switches with objects now. So you could do like an if-else if block or like a switch statement to say, okay, well, if the event came from this button, if it came from this button, if it came from this button, and so on and so forth. Also, this is just like a generic event. This occurs for sort of any event on the button or like the default event, but you could potentially have different types of events that occur, and depending on the type of the event, you could do different things. So action event is the event that occurs for the default action for that control in Java. That's how that works. Okay, so I think this will work. Let's, fingers crossed. Almost. Let's just fix that. Okay, that was a bit of crazy code. Let's see what we actually ended up with. And it'll tell us if we fail. Oh, no, we messed something up. All right. I'm going to have to do some quick checking of the API before I dive too much deeper here. I actually need to declare buttons 2 and 3. That would be a good start. Okay, that's button 2, that's button 3, and then I'm going to have to quickly check the reference page for Java API. That'll do. Ah. West, center, and east, indeed. Okay, and the joys of live code demonstrations. Okay, that's that. Method get. Java API get action. If anything, we're having fun with the Java API, which is always good to get familiar with if you're not already familiar with it. I find that the API documents are the best way to work out how to do stuff in Java if you get stuck, but it does take a little bit of practice to get familiar with reading them. Now, add component listener. Action. Action listener. Now here we go, add action listener, get action listeners, returned, and oh, it's an array. Here I was thinking it was like returning a list, it was actually an array. That makes everything a lot easier. Okay. It does mean that I have to do a bit of jigging with the array to make everything work, though. Actually, this probably would have broken either way. If L dot length is greater than 0, You might be wondering, Ian, what the heck are you doing with all of this? Hopefully you've sort of picked up by now, but if you haven't picked up by now, what we're doing is we're creating a system where we can add action listeners multiple times and then remove those action listeners from the button. And then when you click the button, it'll trigger the action listeners. And now we get to discover whether Java uses lists or sets in its implementation. We will find out. Okay, third time's a charm. Okay. All right, so button, add and remove. If we click on the button at the moment, nothing should happen because we haven't got any action listeners attached to the button, and nothing happens. If I click on add, it's either going to crash the program. It hasn't crashed the program, that's a win. So that's added a new action listener to the button. When I click the button, you can see that it's now saying the button was clicked in my terminal there. If I add another one, and then we'll find out if we get 2 more or if we just get 1 more. And that was 2 more, so Java uses lists in its implementation. If I add another one, we should get 3 more appearing here. Yep. And then, so I've just removed them all. Clicking the button does nothing now. And we can add and remove. So there are times when you might actually want to do this in your programming implementations of graphical user interfaces, but yeah, that's how that is how actionable, that is how the observer pattern works in practice. Example of how that works in practice. Does anyone have any questions about that? I'll just wait a moment for the live stream to catch up as well. Feel free to ask them again in Piazza. There's the live Q&A and in the discussion.
So just like what you said, for the action listener,
Mhm.
we put all the button and the implementation class in, not in same action listener. It's a good way, is it?
I think it, so again, the question was, for all those listening at home, the question was, is it better to implement a single action listener or define a single action listener with behavior for multiple buttons, or is it better to define separate action listeners with behavior, each with their own distinctly separate behavior? And the answer, I think, is it depends. There might be times when like the behavior of several buttons is like linked together. In that case, it might make sense to have a single action listener that checks to see, you know, which button was being clicked or which control was being interacted with, and do different behavior based on that, while keeping track of like all the shared information for all of those controls. So if it's a bunch of controls that sort of form a group together, that might make sense. Whereas if they're distinctly separate controls, it's probably better to leave them as separate action listeners.
Would you?
I can do an example of, I can try to do an example of that now. It'll be a bit off the top of my head, so this might take a moment, but let's see. Let's say that we wanted to link these two together. So what I would do, I think, would be to say, firstly, action dot, I'm working off the top of my head at this point, so this could get a bit weird, action dot get source. So, I think it's just this. We'll find out. Always a good idea to use an else if rather than just a straight up else here. Okay, I think that'll do it. In that case, then I just need to so I add the button listener to both buttons. We'll find out. Oh, I don't like my chances. What have we got? Variable declaration not allowed here. And actually, that's probably why that was giving us that error just before. I prefer it there, but it'll tell us if it doesn't. Okay, well it's compiled, so let's find out. That seems to be working. That seems to be working. And the action listener object also contains a bunch of other, the action event object also contains a bunch of other information. Let's take a look at that. Here we go, action event. So a bunch of static variables, that's nice. Get source must be inherited from somewhere, I imagine. Here we go. Here we go. Event object, get source. So this particular type of event has a bunch of stuff associated with it that gets imported from other things, but the get source is probably the most useful one. Different types of events in Java will do different bits and pieces. We're getting sidetracked here because the actual specifics of the implementation are not super important. I just wanted you to see an example of it in practice. And I'm not seeing any questions being posted, so I think that just about is going to wrap things up for us for today. All right. I'll be looking forward to marking all of your programming assignment ones over the next week and a little bit. Feel free to post any questions that you have on Piazza. Otherwise, we'll see you in workshops this week. If anyone has any other questions, I'll be here for the next few minutes, so feel free to post them in Piazza or in the live discussion. I'll actually check to see if anyone's posted it in the non-live section of Piazza, because that could be a thing. Nope. All right, well, hopefully that's been useful, interesting, helpful for you all. Next week, or over the course of this week and next week, we're going to be shifting our focus a little bit. We're going to start looking at functional reactive programming, basics of functional reactive programming, and then we're going to be moving on a little bit into event streams and Kafka, and that'll be happening over the course of the rest of the semester, and there'll be more information coming about that very shortly over the next day or so. So yeah, we can look forward to that. Again, feel free to ask any questions on Piazza, and we'll catch you all at workshops.